On behalf of Netnology, welcome to another demonstration, part of the Cisco Be Boundless initiative. Cisco is doubling down on integrating cross-domain architectures which address customer business needs. These simple cross-domain integration examples span Cisco SDX and cloud architectures and solutions while having a laser focus on security, analytics, and automation without technology barriers. In other words, one part of Cisco making another part of Cisco even better. Be boundless. Netnology is one of the top integrator partners and a Be Boundless champion, working hand in hand with Cisco to make Be Boundless a reality. Today we will be demonstrating AppDynamics and Cisco Workload Optimization Manager, or CWOM, integration. The demonstration will include some of the AppDynamics agent deployments, as well as the CWOM target configuration and a few other configurations needed to get off the ground running with this integration. AppDynamics helps to actively monitor, analyze, and optimize complex application environments at scale. AppDynamics also gives complete visibility across servers, networks, and containers, whether on-prem or in the cloud. AppDynamics helps with detailed deep diagnostic capabilities to identify root cause down to the individual line of code. CWOM provides and understands application resource needs at every level. CWOM's AI-assisted analytics proactively makes recommendations to alleviate performance issues. With intelligent automation, CWOM implements resource recommendations automatically to ensure the business performance. CWOM drives public cloud savings with automated selection of cloud instances, databases, and storage based on workload consumption. Cisco AppDynamics and CWOM provide visibility and insight into specific application and infrastructure interdependencies and business performances. With AppDynamics and CWOM integrated, IT teams can make real-time infrastructure resourcing decisions to scale resources up or down to match the application needs. IT teams can better avoid performance degradation with dynamic resource provisioning. IT teams can also have an accelerated mean time to resolution. For AppDynamics on-prem, make sure the guidelines are met according to the system and server requirements in the link below. For AppDynamics SaaS, IP ranges for agents and different components need to be able to communicate with the cloud controller. Further details are in the links below. For CWOM on-prem, you need a hypervisor to deploy the VM with, at least 150 gigabytes or more of disk space, 16 gigabytes of memory, and at least 2 virtual CPUs. For CWOM SaaS instance, communication needs to be allowed from public cloud to on-prem and back to connect with targets on-prem. Here is a high-level topology. For this demonstration, we have a HyperFlex cluster that is running vCenter 6.7 and ESXi host of 6.5. Here is where both on-prem CWOM and AppDynamics are deployed to. We also have a single-node Kubernetes cluster where our AD Financial application is deployed in. All of these are connected to a set of fabric interconnect switches, which then uplink to a set of core switches to the rest of the network. Some assumptions for this demonstration are: AppDynamics is already deployed and set up. Agents have already been deployed and applications set up. AppDynamics is already licensed. CWOM is already deployed to a hypervisor, and the first-time setup has already happened. CWOM is already licensed and integrated into the hypervisor. Let's get started with the live demonstration. The first thing we are going to go over is a database agent install. For this process, we need to log in to our AppDynamics controller. Once into our AppDynamics controller, we are going to click on the tab labeled Getting Started. From the Getting Started tab, we are then going to click on the Getting Started Wizard button. From there, we can select what type of agent we are going to be installing. For this demonstration, we need to select Databases. On the Database wizard, in the drop-down, we are going to select MySQL. The next section for the controller should already be pre-filled out. If not, fill in the details needed. Finally, we are going to download the agent by clicking the Download button. And after a few minutes, the zip file of the DB agent will be downloaded. After the DB agent is downloaded, we can see on the AppDynamics controller that it is waiting for a connection with the agent. From here, we need to copy the zip file to our MySQL server. From our MySQL server, we need to create a folder to place the DB agent in. As you can see, I am in the Home/Administrator directory, where we will do this with root access. Now we can go ahead and create a folder to place the zip file in. Then we will change the permissions of the folder and put the zip file in that location and wait for it to finish uploading to our server. Once the zip file has finished uploading, we can then CD into that folder and unzip the DB agent zip file. Once things have finished being unzipped, we can then ls the directory to see all that has been unzipped. Next, we need to cd into the conf directory so we can modify the controller-info.xml file. So we are going to vi the controller-info.xml to get into it and see it. From here, we need to verify the controller host line, the controller port line, and the account name line. All these should be pre-filled out. At the bottom of the file, we need to add a few lines that will pertain to the AppDynamics application. To save time, I have already filled these in. For this case, we are going to add the Force Agent Registration tag to true. Then we are going to add the application name this device belongs to that corresponds to the application name in AppDynamics. Then the node name of this node and a tier name. Once all that is added, we can then exit the file and write our changes. At this point, we are ready to start the DB agent. We are going to cd back one level, and we can start the DB agent by running /start DB agent. Once started, you should see a Started Default Database Agent Successfully message. Then we can continue back to the AppDynamics controller. Back on the Database wizard in AppDynamics, we can now see that the agent is showing as connected. Keep in mind, this may take a few minutes, or you may have to refresh the page and reselect the database type in order for the agent to show as connected. For the database collector section, we are going to need to fill in a few things. The name of the collector, in this case, demo-mysql-03. The fully qualified domain name, or the IP address of the database server, the listener port for MySQL, and the MySQL username and password for an account that has read privileges into the database or databases to monitor. For this case, the root MySQL account will do. Now we can go ahead and hit the Continue button. From here, it will take a few minutes for the database to connect with the AppDynamics controller. This is a good time to generate some load on the database to help AppDynamics DB agent read into the databases. After a few minutes, we can see that the databases are connected with AppDynamics, and we can go ahead and hit Continue. Now we can see the collector name demo-mysql-03 in the Databases tab. We can click into that collector to see more details about the databases on that server. That was just one agent install of the few agent types for AppDynamics. Next, we will create a user in AppDynamics for the integration into CWOM. From the AppDynamics home screen, we need to click on the cog icon in the top right corner of the screen and select Administration. From the Users tab, you can see I already have a CWOM user created. But if we click on the plus sign Create button, we can see the requirements to create a local account for AppDynamics and fill in the needed fields. The account created for CWOM will also need roles assigned to read into AppDynamics or make changes. So for this demonstration, we added all the roles to the account. We also need to make a note of the account name in AppDynamics. This will be used in the target configuration of CWOM for AppDynamics. To find this, we need to again click on the cog icon in the top right-hand corner and select License. Then, navigate to the Account tab to see the Name section. This is the account name. For this demonstration, you can see the name is Customer 1. Now we can jump over to CWOM to configure the AppDynamics target. Once logged into CWOM on the main dashboard, we can see the information already being displayed, showing some virtual machines, some hosts, and a few other things. This information is coming from the vCenter target that has already been configured and a Cisco HyperFlex target as well. To add a target, we are going to need to click on the Settings icon on the left-hand side of the screen. Then we are going to need to click on Target Configuration. From the Target Configuration screen, in the top right-hand corner, we need to click on New Target. Then click on Guest OS Processes. And finally, click on AppDynamics. This will bring up the AppDynamics Target Config screen. From here, we need to fill in the information: the host name of our AppDynamics controller, the port number, the username, which is the CWOM username we created earlier with the @ sign followed by the account name, then the password for the CWOM username. We are not using SSL or a proxy host, so we do not need to fill this in. Then hit Add. And after a few minutes, the target will be validated and added, showing green next to the target. After adding the AppDynamics target, we can then go back to the main dashboard by clicking on the Cisco icon in the top left-hand corner. From here, we can see the diagram has changed a bit. We can now see Application Server, Business Application, and Database Server, and how they all correlate with each other. From here, we can click on Business Application to bring up the overview of all three applications in AppDynamics. And note the health and current pending actions and other statistics. We can then go to the List of Business Applications tab to see the three applications. Here we are looking at the AD Next application, so we can click into it to see more details about the application. Currently, it looks like the application is all healthy and running well. Next, we can go back to AppDynamics to take a deeper look into our AD Next application. From the Applications tab, we can see the AD Next application and click into it. From the dashboard screen, we can note the communications diagram of the application. We can also see the transaction scorecard and errors being seen by AppDynamics, as well as the response times. We can also note the application changes and click into it to see what's going on. From here, we can see that a few components to the application keep crashing and restarting. Because AppDynamics and CWOM are integrated, we can move over to CWOM and look at the containers that are running this application. From the CWOM dashboard, we can see that our Kubernetes cluster is now also integrated and giving us the containers view in the diagram. From here, we want to go into the containers area to take a look. We can see that one of our components of the AD Next application wants to increase the virtual memory. Because CWOM by default is only set up to recommend and not automatically remediate, we need to click on the action. From here, we need to check the box next to the item we want to apply, and then hit the Apply Selected button in the right-hand corner to allow this action. After a few seconds, this will go all the way through, as you can see that it is running now at 5%. And now that pending action has gone through, which means that change has been made to that container object. After the change has been made to the auth services in CWOM, we can jump back over to our AppDynamics application and monitor the changes. We can still see a few tiers have restarted. Back on the AD Next dashboard, we can monitor the application's progress once again. We can see that the response times have decreased. Now we are going to look into how to reclaim unused resources from an application in CWOM. Starting on the CWOM dashboard, we click back into the container's objects to see the scale-down actions. From here, we can see the ADFIN Next auth services, and now CWOM wants to reclaim some of the virtual CPU as it is no longer being used by the application and is unnecessary. So we are going to click into this action, check the box, then apply to reclaim these resources. Keep in mind when doing a reclaim, the application container requires a restart to do this action. And after a few seconds, the action has gone through completed. Finally, we are going to go over how to change the default policy for containers in CWOM to allow automatic resizes instead of manual. From the CWOM main dashboard, we are going to click into Settings. From Settings, we are going to click into Policies. From the All Policies screen, we can search for the policy we are looking for if a custom one was created. But for this demonstration, we left all the default policies. So we are going to find the Container Defaults policy and click into it. Finally, we can see the Action Automation section. Here is where we want to change Resize from manual to automated. Then apply and save. This will allow all resizes on all containers to be automated and actions allowed without any human interaction based on what CWOM recommends. For further details of this integration example, please refer to the step-by-step integration guide. This concludes our demo. From all of us here at Netnology, thank you for watching.